All right, I wanted to do one more inverse function. We talked in the last video about how it does the opposite operations in the opposite order. We also talked about how you can take any particular point on the original function, switch the x and the y values, and you get its buddy point on the inverse function. We talked about the whole graph is a reflection over the line y equals x. So we'll look at each of those ideas in a little bit more complicated of an example here, where there's like, I don't know, 4 operations going on. So there's going to be our original function. Let's change this to a 5 just so I have some different numbers. Okay. I've got a couple operations here. Let's use a point to see what happens. Let's say I care about the point x equals -1. My original function says what you're going to do is do -2, plug in -1. Let's write out what the operations are going to be. First operation is adding 3. Second operation, squaring. Third operation, multiplying by -2. Fourth operation, adding 5. So let's go through that. First, we add 3, so we get +2. Second, we square, so we get +4. Third, we multiply by -2, so we get -8. Fourth, we add 5, so we get -3. So what I'm saying is that the point -1, -3 is on the function. And it is. Now, I can guarantee as well that the point -3, -1 will be on the inverse. We'll get to that in a second. Let's choose a different point. Let's choose a y value here. Let's say I care about when y is going to equal 3. I'm going to do the opposite operations in the opposite order. So before, I did +3 squared times -2 plus 5. I'm going to do the exact opposite on this here. So we start by writing out our equation with the number 3, replacing the letter y. The last thing I did on the function was +5. So first thing I'll do on the solving is -5. The steps of solving are the same steps of the inverse. If you know how to solve an equation, you know how to find an inverse. So I did -5. Then I do divide by -2. So I get 1 equals x plus 3 squared. Then I square root it. When you take the square root, you need to consider 2 answers, +1 and -1. And last, I subtract 3. So I get 2 different answers. +1 minus 3 and -1 minus 3. All right. Excuse me. So I know that on the original function, I've got -2, 3. And I also know I've got -4, 3. Now I know also that on the inverse graph, I'll have 3, -2 and 3, -4. Now, if you're paying close attention, you'll notice that I did not use the word inverse function. I used the word inverse graph. And that is because the inverse is not a function. And I know that because I just plotted 2 points that are vertical of each other. So that means that for the x value 3, the inverse has two different y values. Can't be a function. But I can get the equation for the inverse by following the 4 steps I used to solve when y was equal to 3. First step, minus 5. Second step, divide by negative 2. Third step, square root with the plus or minus. That's why it's not a function. Fourth step, minus 3. So what I'm going to do is write out that function. Oops. I don't know how I did that. There we go. Okay. So we have y. I could use the inverse notation if you want. So let's do f inverse of x. Nothing to be scared of. Okay, what was the first thing? Minus 5. So I put it in parentheses so it happens first. What was the second thing? Divide by negative 2. What was the third thing? Square root with a plus or minus. What was the fourth thing? Minus 3, not under the square root. So that's the function. To actually type it in to Desmos, I have to type it in as two different branches because there's a plus or a minus. So I will do, and you can just type the letters SQRT, by the way. I'll do the, to get the square root, I'll do the positive arm first. You can see here, that covers the top half of the inverse. The bottom half of the inverse, I can just copy and paste and stick a negative in front of it. And that's the plus or minus. So blue is the plus, green is the minus. You can see that the inverse is not a function. Even though the inverse is not a function, it is still a reflection over the line y equals x. Look at every one of those points, just like I showed you in the previous video. Every point can be connected to its buddy point, and the line y equals x is the perpendicular bisector between every point on the inverse and its original point on the function right there. Okay, so that is how inverses work with a little bit more of a complicated example. Again, please ask questions and comment if there's anything you can do. This is a big idea that we're going to keep working on for a little bit longer. Thanks for watching.